Well, after the Marcg EM27 yesterday, and you know what, it did actually improve a bit. I think the deviation was 1.8 by the time it's gone back to the customer. So this came in from our mystery benefactor Alan from North Lincolnshire. I'll just make sure there's nothing written on there that, yeah, that's all right. That doesn't reveal him. So it's a Commtron CB40F. So I've actually been looking forward to doing this. If I can just reach where we can put the box. Good. Well, that looks nice. It's got some wrong screws in. We can deal with that. And the power connectors in one piece. It's a January 82 one. And what does his note say? Another radio for you. It receives, transmits, but when it's been on for a while, it goes quiet as if someone is keyed up, and it stays like that until it's turned back off and on. Yeah, right. Well, let's hope this is one we can fix. 1st of March, that I do know today. So normally, obviously it's the Marcg 4E type chassis. Normally they're going to do 4 watts, and if they don't, it's 3.95. And normally they're going to receive just under 1 microvolt. So it's what you're going to expect. Sometimes the meters are adjustable for S, and sometimes they're not. If they're not, we don't modify them. Serial number 7109029. Now, sometimes we have a Maxon power lead on the bench, since we manufacture them, and sometimes we don't. Now then, I'll go over to stores department and I will borrow one of our for sale ones from stock. Right, I'll plug this in instead. So I'm not going to tread too carefully because he's already says it's been powered up. So we will power it up at full 13.8 volts, but we'll be current limiting it as usual to 1.6 amps. I don't think these sets normally take more than about 1.25. So we'll use a standard replacement mic. Now subsequently, Alan has kindly sent another box. We sent about another 2, I think, and in one of those is a mic which would fit one of these, but because that's going to be faulty, I don't want to kind of as you can understand, we don't want a random event on a random event. So what we'll do is to use the already made up Commtron mic. Oh yes, it faded away. Right, I'll switch picture in picture on and I'll stand up to see if it's appeared on the monitor. It's appeared in the wrong place. So right now, as it's coming, it's doing, helps if I put the right screen on, right camera. I think we'll go over to the low power. It's just 2.8 watts. on channel 1. It's 2.9 watts. And on channel 40, what do you reckon, 2.7? No, 2.85. On low power, I'll go back to channel 20. Oh, it's still in. Oh, it's 100 milliwatts. And then back to normal power. The transmit current is 966 milliamps, which is nice and efficient. There's a 1 amp power supply was on the market at the time in 81, and I used to think, how many sets could you actually run on the 1 amp power supply? Was it Taran? Oh, it was FKI, wasn't it? Basically all it was a 7805 voltage regulator with its earth up so that it produced 13.5 volts instead of 12, and it really simple thing. And I thought, 1 amp, surely they need to be either 2 amp to be on top of the job, or at least 1.5 amps. But anyway, this is a set which, as it stands, would actually work on a FKA power supply. I actually bought one of those. I don't know whether we ever reviewed it. But I bought one of them, and I had to pay real top whack for it, but I so wanted it to see what was inside. And I had to pay something stupid like 30 quid for it. Anyway, that's a good deviation. I'm diversifying. Whoa, that was good, wasn't it? What? Whoa, it's 4.5. That's a contrast to yesterday's set. And now we'll look at the frequency. So normally, if this had been met, come on, let's put a different camera on. Thank you. So it's 27,79086. So it wants pulling up, but it's not illegally low. So let's look at what the RF meter says when we key up. Knowing on the test set it's 2.8 watts, and it shows 1.2. Meter lamp's working. Internal speaker's working. There isn't a mic, but I'm going to look at that other one, which is sent in at the end of this job. So we'll go over to the SINAD meter, and we'll just dial in this frequency into the signal generator. So we want 27,79086. So I'm not putting the correct frequency in as 27,79125. Well, that would be an unfair receiver test when we know the radio's off frequency. 79086. That'll do. Oh no, it won't. Come on. Quite difficult to get these things absolutely on. 27,79086. So I'll put 100 microvolts on. It's showing that as, well, we'll come to what is 9. We can just about get 9 at 10 millivolts. So plug in the extension through to the extension speaker for the test instruments. While we're at it, we'll plug in the PA speaker. I think they're a bit interactive on these sets, which is annoying. So switch on the SINAD meter, which of course is 110 volts, being Motorola. And let's see, just a bit more volume on so it's a fair test. So right now, this radio is doing 0.95. And before I forget, we'll do the 10 just before the test set does its times tables, which it's doing right now. That's 0.76. And then we'll see whether it does 20. Some sets do, some sets don't. So it's all about noise, a bit like my test set's doing at the moment. Want some capacitors changing in the deviation section. 2.25. And then the squelch, we'll put the squelch to full. I like it to be 100 microvolts to open. It's actually 1 millivolt. So tight is 1 millivolt. And at the sensitive end, .75. It wants adjusting, but it's quite usable. So as it stands, fault. I realise it goes quiet and that. Fault aside, that's working reasonably. So I'm now going to do PA. Testing 1 2, testing 1 2. And annoyingly, it comes out of the internal speaker, the external speaker, and the PA speaker. So that's working. I don't think it was well thought through on these on this chassis. And that's absolutely fine, and that's absolutely fine. Right, time to open it up. They don't normally suffer from capacitor problems, but that does sound a bit capacitor-ish. So for people struggling to get black screws, there are M3 metric screws, and they are 6mm long. I've not put the soldering iron on, which was remiss of me. This is in lovely condition inside. Back to his notes. Oh, is it on the lid? Back to his notes. Receives and transmits. When it's been on for a while, it goes quiet. You know, that, I know it sounds stupid, but it could be that could be as silly as a dirty volume control. But it certainly did it for me when I initially tested it. I'll have to get the Servisol with a straw off Mr. Chippy's bench. I've said before, we're not going to go through the VCO on these because you've got to add extra parts in to do that. One day we'll get a setting where it's been messed with and we will have to add the extra parts. At the factory they're set up on a pin jig and they just don't need the extra parts to do it that way. It cuts their costs down. So the test point isn't present until you put 3 extra parts in, usually. Oh, it has got the extra preset dangling on the meter. Right, so we'll go through the transmitter and then I'm going to have to take a break. Go over to the meter. So we're at 13.8 volts. I now go over to the 30 watt range, so we're now at just under 3 watts. So that was already peak. That wasn't though. That was. That wasn't quite. We're at 3 watts. This doesn't look like it's ever been messed with. It looks absolutely lovely. And then we've got the one down there. This is one that's not going to. Now, the other thing is checking that some of these other coils are actually pushed closed. So this one, this is all in the service manual, I'm not making this up. This is the opposite to the coil stretcher. This is the coil compactor. Now I think that's where we're going to be with it, folks. But I'm going to go through it again. I mean, it's warm now, so it's going to be doing a bit less than it has been. That's better. So just that checking that those were compressed has made a difference. I think we're at 3.8 at the moment. So 3.8, 3.9. I think by the time this is cooled down, that will be 4. So it was this one. This one, we just needed to make sure we're actually compressed. But not overlapping like that is. This might be where our missing 100 milliwatts is. 3.9. So when we cool that, when that set cools down, we'll test all that again. I may as well set 400 milliwatts though, because I don't think it's not going to be far different. So we'll just go over to low power and go on the low range of the test set. So at the moment it's now doing 100 milliwatts. And we want it to be there, 400 milliwatts. (400 milliwatts). So back to normal power. It's now drawing just over 1 amp. So we need to bring the deviation down. That's something which had been messed with. Try it there. Wallow. That's it. Just using the oscillator, I get it just to about 2, and then we just check it with the wallow. So we've got a peak. So I know it's averaging 1 2 1 2 wallow 1 2 1 2 1 2. It's averaging around a 2.2, and then its peak is 2.5. I don't want it to go above 2.5. So we've now got. I'm not going to fill that in because it needs to just cool down a bit after being in transmit for 10 minutes. We'll come back to that, that'll change. So it's now 2.2 to 2.5 kilohertz. We're not doing VCO. We'll pull up the frequency, if it will. Just go over to the frequency counter, and the crystal trimmer there, next to the crystal. That's going down. Well, it doesn't matter which way I turn these, it'll be the wrong way. There we go. 27,79126. So it's just a tiny one over, so that it can drop naturally with age, as will happen. So let's see whether we can do something about this RF meter, or whether it has now changed. But it was 1.2 watts indicated earlier. It's now reading 3. Well, of course, we brought the power up on the radio. So we'll just adjust the preset, see whether we can get it to say 4. We can, bang on the 4. Let's go into low power, see what it says. It's kind of between the 0 and the 1. So it's not so stupid. And remember, when you put this on an aerial, it may not read anything like what it is on a dummy load. So we've set it with a dummy load in the test instrument to 4 watts. But when you put it on an aerial, I'll do that right now. I'll just put it on the roof area. Now the SWR on this, on the channel we used, on channel 31, it's about 1.8 to 1. But on channel 20, in the centre of the band, it's 1.5 to 1. So, there we go. Let's see what it says now. It's just over the 4, but it doesn't mean the set's doing any more power than it was. It's you know, if it bangs across and hits the end stock on the air, it doesn't mean the radio's doing more than 4 watts. And conversely, if it only just moves, it doesn't mean that it's suddenly only doing half a watt, because it isn't. It's still doing 4 watts, because that meter is reliant on the impedance of the aerial being as near to 1-to-1 as possible. Unlike the modern sets, where it's pre-programmed just to read a whole pile of fairy lights, which mean nothing, even if, when the set, you take the output transistor out, it still says it's transmitting. It's what I call a glorified transmit light. So I've checked the channel 9, we know they work. I'm going to clean those as a thing. That's now reading 4 watts, so that's spot on. So as we work down this, so I'm going to take a break. This is going to stay on for the next couple of hours while I do some other jobs. Right, so here we are back with the receive bit, and we will put the oscilloscope on the screen. I'll put an S9 equivalent signal of 100 microvolts, and we'll pop enough volume on to get a meaningful trace. And as I've said before, on this chassis the detector is something which can drift. And again, this could be the issue that was noticed. Yeah, well, it wanted resetting. So that's that done. Let's see whether we get a bit more receive sensitivity. It's already okay. My goodness. Massive improvement. Didn't expect that. Struggling to get into that for the wiring. There we go. I don't think I need to go through it again. let's see where we are now with the sensitivity. So there's our 12D bit. Oh, sorry, I've not been showing you the SINAD meter. The remote sensor's in a silly position. So for 12 dB SINAD we now have 0.58. So that's a good improvement from 0.95. So let's look at 10 dB. It's about there. 0.52. And see if we've improved the 20. This is really down to noise, and it's now 1.6. So while we're just on the form, I'm going to go back to transmit, and we'll just check if it's still doing 4 watts. So this set's been on 3 hours since that we did the transmitter. So let's key up. It's bob on 4. So it's 4 on channel 20. Let's go to channel 40. .95. Channel 1, 4. Good. Right, I just want to look at current consumption. 1.04. So it's not a massive increase for, well, definitely 25% more output power, which just goes to show how the lining them up correctly helps. So let's look at the meter. So I'll put the attenuator on. So we want S9 on the meter, if we can do that. It's showing, what, 3 at the moment. So they've added a preset onto the back of the meter. Yeah, that's all over the place. Let's just give that a clean. It's actually snapped off. This looks like someone's added it at some time, to be honest. Now it might be possible, because these are silver plated. Let's turn the volume down. It may be possible to solder this back on. So if I can find my fiberglass brush, which is actually here. I'll just straighten that out. We might be able to solder that on, we might not, we'll find out. Just turn the power off just in case. This is another set I'll have on overnight, just in case there is a malfunction. It's possible there's some capacitors had to do a bit of reforming, but I can't see there's any malfunctions on those. A friend of mine used to work in a kitchen, commercial kitchen, and they had a gentleman who worked there, I think he was the head chef, who was called Malcolm, and they used to refer to him as Mal. But my friend Bob used to refer to him as malfunction. That's really solid now. Switch the set back on. Well, that looks about right. Right, so that's just got the squelch. I'm going to clean these potentiometers, and we'll just do the squelch now, and that should be it. Oh, let's see how far we can hear this down to. So if we go to 0.3 of a microvolt, you can still hear it. Not as well as we could hear that Maycom yesterday. Now we'll just put this, but better than that Cobra. So can we hear that new tone? Let's see how far we can hear that to. 0.15 of a microvolt. So that's good. Squelch. I'm going to put the tone back to 1 kilohertz. I've put the squelch to full. Let's see now, because we've retuned the receiver, it may be different. I want it to come in at 100 microvolts, 1, 3, 10, 30, 100, it doesn't. So we'll just do the preset. Yeah, which way? Right, it does not come in at 100 microvolts. So let's see where it does come in. This is the best I can do. It is 140 microvolts for squelch tight. So 140 microvolts is a lot better than 1 millivolt. Now the sensitivity, let's see where that is. So we'll now turn the signal generator to standby. I'll park it at 0.3 of a microvolt. Turn the squelch down. Set threshold. Switch the signal generator back on. See when it comes in. It comes in at 0.44. It leaves at 0.32. That'll do scratchy corner nicely, thank you very much. So 0.44. 0.75 was okay, but 0.44 is going to be much better. Good, well, it's working out nicely. So I'll pause the video, I'll go and get some Servisol with a straw. Okay, so that's done, and that's nice and smooth. So we'll leave this on and we'll do our test tonight. Put it back together. And I will leave it on all night and just make sure it doesn't malfunction. And then we'll look into the microphone that Alan also kindly sent. So it's coming as he sent this as a separate entity, and I think there's a note with it saying it doesn't work. So, as you know, the microphone inserts, or elements, whatever you want to call them, are prone to failure. Now these are 40 years old. Alan's fingerprints there. Right, so we've got some screws with this. Put some new ones in as well. A bit of wax in that one. So Alan says he's resprayed this. I think he did, and it certainly smartened it up. Oh, and the TX light works on this one as well. Had a note from Every, as in the courier company, saying that they've failed to deliver something to us today. I had to go to the vicarage for a quick half-hour meeting. During that time, of course, it's inevitable that something tries to be delivered. You know, when people send stuff, and they say, was it normally being trade, the dealers know this, don't ask for a signature, because the chances of anybody being in are pretty slim. I mean, we are in the middle of nowhere, half a mile from the nearest neighbour. There's a lot of security cameras here, and the couriers know where to stash stuff, and that place where they get stashed has cameras as well. So there isn't a danger of non-working radios that arrive for repair being nicked. So it's always been a problem, because I'm at work, and yes, I'm working now, and I'm workshops are within home, but we are in and out all day. Right. Let's put it on the aerial. No, we won't. We'll look at the mic first. Pause the video. Right, so it's not one to go with this particular set. It is badged Maxcom, but it would go nicely with that 6E, for example, if we can get it to go, or change the insert, which isn't perfect but can make it at least work. So let's put the camera on our deviation meter. Wallow. Well, you know what, I'll tell you what, we'll switch this to PA. So unplug that and plug in the public address speaker. 1 2 1 2. Now these are flimsy. Always were flimsy. Always were problematic. The joke was the radios came with a 2-year guarantee. The mics came with none. And it's absolutely true. The mics came with none. Oh, that's not going to do anything, is it? Someone's putting an electret in it. Right, that's not going to work. So, an electric microphone has to have a voltage for its built-in field effect transistor amplifier. So, unless there's a power feed, well, no Maxcoms are expecting that, so that's not the way to do it. We unsoldered it at this end. Right. Yeah, that just isn't going to happen. Now, I did order some from China. I'll see if I can get one to fit. Might have to go into the organ workshop and saw one down. Okay, so we've put the Cramden insert in there by sawing it down a bit and fiddling about, and 1 2 1 2, testing 1 2 1 2. So they're not as good as they should be, but again, it's better than a mic that doesn't work, and it's nice to have that to go with something, which we will do. But as far as this set goes, this will be on the standard replacement coffin mic. Testing 1 2. It's got more gain. Let's put it on the aerial. Roger. Okay. Well, when I'm not shorting my power lead out, there we are. We'll do an on-the-air test later on with that. Thanks very much once again, Alan. And that's very nice.